Okay, this is the study hall for October 30th, and we are doing more of what we did last time, which is mental flexibility in Quant. Remember how this translates? When we say mental flexibility, this really means just having lots and lots of ways to do stuff, solving problems in lots of different ways. And what that translates as for most people is non-textbook methods, just because most people tend to favor using methods from school, all things considered. So for the most part, this is going to be a lesson that focuses on doing problems in lots of ways, including non-textbook methods. All right. So we went over the rules just now. We did that whole bit. Let's just show that copyright screen again. There it is. Okay, all of these problems are from the GMAT prep free software and our copyright GMAT. So the free software problems, of course, can be redistributed because they are free. But please don't do the same thing with the paid question packs. If you submit those, we can't use those on here. So there's your copyright notice. Let's go ahead and jump to a problem. Okay, let's see. How about this one? And remember, this is a data sufficiency problem. So again, we assume that you guys are on board with this enough to know what the data sufficiency answer choices are. But here is where you find the responses to multiple choice questions. Go for it. Okay, at this point it's kind of been a while. So if you don't have something, you should probably have something by this point. If your name is Pranav or Riz. Tablet, I guess, yeah, TK. Okay, tablet people you can put in answers to. Pick something. I mean, the answer choices to this problem that you guys have picked are almost random by this point anyway. So here's what the class has so far. I mean, people don't like C apparently, but these responses are more or less random. So if you have to guess, you should certainly not feel bad about guessing. Okay. Well, this problem looks humble at least, but we are all over the place with it. Let's take a look. So with data sufficiency, there are basically two approaches in the world. If you look at this from a large enough standpoint, there are your textbook style methods, and then there is what else. We've done it in a bunch of these study halls before, if any of you guys are veterans of the study hall. But what is basically the way to approach data sufficiency besides using things like algebra? You can test cases. Excellent. Right? You can just plug stuff in there and shoot for not sufficient. So that's what my testing case is. You just throw it in there and see if you can get at least two different things to happen. So let's take a look at this kind of problem using this sort of approach. Then we'll see what happens if we try to throw algebra at it later. Let's do that. So first, with any yes or no problem, you have to make sure that you understand what you are even trying to do in the first place. So let's make sure that we do. So we have x to the fourth plus y to the fourth. Is that greater than z to the fourth is the question. So here's what you want to do with yes, no's. I think we have done this as the topic of some sort of study hall session before. But when you see yes, no, data sufficiency questions, regardless of how you're going to ultimately approach them, the first thing you should do is translate. yes and no into specifics. Because the problem with yes and no is that they are not math. They don't emerge from the problem as you work it. So you don't want to keep thinking about the words yes and no. And then translate sufficient and not sufficient. And actually you should translate not sufficient first. We'll see why in a second. And only then should you figure out how you're going to organize this. Okay, so in other words, there's my question right there. So let's translate yes and no. A yes to this question means exactly what it says before the question mark. It means that x to the fourth plus y to the fourth is greater than z to the fourth. What does a no mean? It's the same thing except with what sign? Gonna not less than, not only less than. Yeah, it's less than or equal to, right? Because every case for which greater than is false. So in a problem like this, it's probably not going to matter that much. But if you had a problem about like number properties, that can be a really big deal. Because if things are equal, they will give you a no to them. So less than or equal to. And then the translating the sufficient and the not sufficient parts. Once you have these, as always, this part is always the same, but you should still make sure you can do it. Sufficient means you can get both of these. And not sufficient means you can't get both of those. If you can get both outcomes, that is not sufficient here, because that means you have two answers to the question. That's what you want to define first, because that represents a concrete outcome. It is a goal that you can actually try to achieve. You can set out with, I'm going to try to make both of these happen. As opposed to sufficient is the opposite of this. Sufficient means you cannot get both of those, which means you're stuck with one. So you can see the difference, right? Because one of these is a concrete goal and the other one is not. You can't really try to be stuck with one outcome. Like if you're testing cases, then this represents success at getting both things to happen, and this represents failure to get both things to happen. This means you tried and you couldn't get one of them. So just keep this in mind at all times when you approach yes/no data sufficiency questions. This is going to be your goal. In general, with testing cases, your goal is always to get not sufficient. So you're trying for. Okay. So let's talk about how to set this up. How are we going to set this up? How are we going to organize it? Because the way that you organize something like this is super, super important. Because if this devolves into scratch work, it's not going to get very far. I mean, that's the single biggest missing element for a lot of people, is they just don't organize the problem. So let's make sure we get off on the right foot with that. If any of you have seen me do testing cases in any of the previous study hall sessions, I pretty much go about the organizing on the same way just about every time. Does anybody know what that is? It's nothing too complicated. A couple people are typing. Okay, it's in the form of a chart, although when I think chart, I usually think of something with rows and also columns. And in this case, it's more like just columns. So, but unless there's a different kind of organization that is specific to the problem. For example, if you have an overlapping set, then you're going to make that overlapping set grid thing. And if you have various other types of problems, you might make special charts for those. But if you don't have any special type of organization that comes to mind, at least, you should just make columns. No special organizational device comes to mind. And make columns. Just a column for every step of the thought process. So when we test statement 1, for instance, let's actually do statement 2 first, because this seems like an easier entry than that does. So let's have squared. So let's do statement 2. And what's the process for statement 2? Like, what are we picking? Where do we start? And then where do we go from there? Well, I mean, that's what that's what you're gonna put in. But I mean, what is the process? Yeah, you actually have to start by picking X, Y, and also Z. So let's make columns for those. So let's pick them all. Pick X, pick Y, pick Z. All right. And then what do we have to do? Like, what criterion do those have to satisfy? They have to satisfy statement 2. I mean, this sounds silly and basic because, well, we're working with statement 2, so of course they do. But what I would strongly recommend doing is still writing in a checkpoint. Like, actually check, is X plus Y actually greater than Z? Okay, this is not the answer to the problem. This is not that part. That comes later. This is just making sure this actually counts as a case. So if this is a no, then you would just cross off that row and go again. All right, once you have that, then what you're going to do is then you're going to start addressing the question. This plus this greater than, and then that. So x to the 4th plus y to the 4th is one side of that. And then the way I would do this is I would leave room between these columns for an inequality symbol, but you could also just make that your last column if you wanted to. And then notice that these two goals, these ones that are here, that's what I'm going to put as this column right here. Less than or greater than, or less than or equal to or greater than. And then these are all columns. So I mean, notice this doesn't take very long to set up. And the point is that it is extremely organized. Like once you have set this up, you can, because the problem is the math that you need to do these things is not super complicated, and the thinking of the numbers is not a feat of amazing, incredible genius. But the reason why people don't do it is that they're spending way too much of their brain power on trying to remember what the heck they're even supposed to do in the first place. If you don't have this kind of organization, that occupies a lot of thought space, as it were. But now it occupies none, because you know exactly what you're supposed to do at all times. So, okay. First case can be random, because remember the goal is to get two things to happen, but the first thing can just be whatever. So let's just pick a really easy first case, like 1, 1, and 1. Is 1 plus 1 greater than 1? Yep. Okay, this is 1 plus 1. This is also 1. And this is greater. All right, we got that to happen. Once this happens, what's that red circle right there? What is our only goal in this earthly life once that happens? Your goal is to get less than or equal to, which I'm presuming is what the plus sign is supposed to be there. Yeah, now just note, again, make sure you don't forget, the first case, your first case that you test, can be random. It doesn't have to be. If you have an overall scheme in mind, then frankly that's probably better. But what we get a lot of on the forum is posts from people who are like, I don't know how to get off the ground with this testing cases thing. I don't even know what to put in first. The good news there is you can put in whatever the heck you want first. That's just cool. So all right, now our goal is to get this to be less. While still maintaining this as greater than. This is where Anjal, I'm going to go pull what Anjal said from up there. This is definitely not the only way to do this, but one way to do this that is pretty straightforward, actually, is to just pick a really big negative number for z. Yeah, you can use the options that Anjal put there, or we can even just keep two of the numbers that we've used here. We can just keep 1 and 1. And make this like -1,000. Okay, well 1 plus 1 is definitely greater than -1,000. So then this is 1 plus 1, and this is going to be very, very big. What's that, 10 to the something big. So this is definitely not, 2 is definitely not bigger than 1,000,000,000 with all those zeros after it. So this is it, and we got it, and we win. And I mean, this may seem like a silly number to put in there, but as far as reminding yourself, this is probably more forceful than using -2. Because the thing is, if you're looking at your work, and your work has -2 on it, it doesn't look special. That looks like you're just tossing numbers in there. Whereas if you have -1,000 on there, then you can take one glance at that when you review the problem, and you can be like, I totally get it. The point is that I can make this as big as I want, because this will still be greater, but then this goes positive. So you may want to use very conspicuous numbers like that just to make your point. So statement 2 is not sufficient. Okay, that does it for statement 2. Any questions? Now let's talk about statement 1, which is more interesting. Because there's not this easy cop-out with just tossing a negative in there. So as far as the columns go, there's actually only one column that is different. Which column is different for statement 1? I mean, you still have to pick x, you have to pick y, you have to pick z. Yeah, the check is different. Now the check is x squared plus y squared. Is that greater than z squared, not just x, y, and z? And then this is the same, and this is also the same, and this is also the same. Everything else is the same, so this is convenient. We already made the columns. So what I'm going to do is I'm going to make this smaller so that I can buy us a little bit more space there at the bottom. Here, now that I can erase those actually, now that we have all that. Okay, there's a little bit more room. Let's take a look. Well, again, we can pick our first case to be random again. In fact, 1, 1, and 1 will do us just fine. 1, 1, 1, because 1 plus 1 is still greater than 1. And this is 1 plus 1, and that's 1, and that's still greater than. All right, so you get the drill. Our only goal in this earthly life, again, now is to get less than or equal to. What kind of numbers? Does anybody think of any types of numbers that might do that? You don't have to use special types of numbers, but this is where you want to start. I mean, if you really have no idea, you can start throwing random numbers at this. If you use 0, 0 is probably not such a hot idea, although of course you can throw at it. You can throw it at it if you want. The problem that I have with 0 is that you're trying to, if you look at these next to each other, You're actually trying to get this to still be greater than while this is not greater than. And the problem with 0 is that 0 is 0 in both places. So you're kind of promoting having the same outcome by using 0, because 0 doesn't change. So, okay, fractions. Fractions might make things interesting. Because notice that fractions get smaller as you raise them to more and more powers. So, there may be something there. Any ideas which fractions? You guys have, well, yeah, when we say fractions, we do mean numbers between 0 and 1. But I mean someone should throw a set of x and y and z at me. Here, fractions, here's one way that I have in mind to try to approach this. I'm going to try to keep this at 1. Z, I mean. By keeping z as 1, I have like a target because this is still 1. So now I have a much more concrete goal here, which is to try to find fractions so that, because the checkpoint is going to be 1 also. So now my task is much more concrete. My task is to find fractions that when I square them, I still get more than 1. But then when I raise them to the 4th power, I suddenly get less than 1. That's what I'm going to try to do here. So what I want to do then is I want numbers that are just a little teeny bit more than 1 if I add them together here. So like let's say I want numbers that when I square them will be a little bit more than half. So if I say, if I let these be 3/4, then that's 9/16 plus 9/16. That's 18/16. That checks. So I'm doing there, this is a very deliberately chosen pair of fractions. These are not, the size of these is not important. But these are things that when I square them are only a hair more than 1/2. Because then what's going to happen is when I raise these to even bigger powers, 3 to the 4th of what's 81 over 256. Yeah, that's not going to be anywhere close to 1. So we win. You can use fractions. Fractions are a thing. Okay, we just proved it's not sufficient. You might wonder if you have to get so fancy with your numbers. Well, actually not really. Because the other thing about these powers is that 4th powers grow a lot faster than squares do. So if you just actually, you don't even have to get fancy with fractions. You can just take whole numbers that have the same sort of idea, where x squared plus y squared is very, very close to z squared, but just a little bit bigger. Like for instance, if you take, if you do, for example, if you take 5 squared plus 5 squared, that's 50. And 7 squared is only 49, so the 50 is like ever so slightly. When you do the checkpoint here, it's ever so slightly more. That's a typo. I'll fix that here in a second. I mean, we don't have to do this case. This is just an alternative to working with icky fractions. That's all. 3, 3, and 4 is probably going to do the same thing that I'm doing here with 5, 5, and 7. Yeah. So in fact, I don't want to raise 7 to the 4th. So let's dispense with those and let's use Rio's numbers. 3, 3, 4. That's going to be 9 plus 9 is greater than 16. That checks. And then yeah, 3 to the 4th is 81 plus 81, and this is 256. So that's less. And we win. In fact, this is pretty much the same case as what we have with fractions there. Everything is just multiplied by 4. So it's in the same spirit. But yeah, so you don't need to be super fancy and special about it. You just have to be deliberate. And you have to be a good bookkeeper. I mean, really, most of this problem is about bookkeeping. Because remember that distribution of answer choices? I mean, we had pretty much equal numbers of people picking everything except C. So there were lots of people who thought statement 2 was sufficient. I mean, admittedly, statement 1 of this problem is a bit more challenging. I'll give you that. Statement 2, on the other hand, really shouldn't be. So if you, but there were like 8 or 9 people who thought that statement 2 was sufficient. Those are probably just guesses, but what that means is that this organization is not there. Because if you just make these columns, there's no way you're going to miss statement 2. It's not going to happen. So just make sure that you put the brain power into making the columns. I mean, you have to, yes, it is effort, but it is definitely worth it. Any questions about this problem? And the way that we've approached it on the board. And again, the mistake here would be to only focus on the numbers that we are plugging in and the math. Because I would wager that for most of you guys who got this wrong, the real issue is not the numbers or the math. I would bet the real issue is the organizational aspect. So if that is, then yeah. Okay, if you combine the statements, I'm sorry, actually we didn't officially do that, although both statements down there are going to work for statement 1 too. Because if you, okay, this is the same case that we used, wow, that's horrible, let me make that look prettier. I should officially acknowledge combining the statements, that is a good point. This case is the same case that is up there. So this is a combined case already. But then with this one, all we have to do is make sure that it passes the checkpoint for statement 1. And it does. So we're good. Because 3/4 plus 3/4 is greater than, for statement 2, I mean. So this actually passes that checkpoint as well. So both cases actually still work for the C versus E step of this whole process. So you're right, we didn't explicitly acknowledge that. We definitely should have. So, but luckily, both cases still work. In fact, I think that it might be that as long as you have numbers that are positive, I think both statements will. I think the statement 2 will always work for statement 1. Although don't quote me on that. Maybe that's wrong. No, that's wrong. Never mind. I didn't say that. Okay. If you are asking that in the form of a question, then the answer is probably no. Yeah, there's not really anything. Remember that you should be cautious about this whole notion of rephrasing in the first place. Because if you make any sort of erroneous transformations of a question, then the whole problem is down the tubes. So you have to be 100% sure that what you are doing is legitimate and is absolutely the same as what you started with if you're going to rephrase things. So here, I don't see any easy way to do that because you can't factor this. And you can't get this to reduce down in any easy way. So I'm tempted to give you a no to that, but the better answer is just to say if you have to ask that as a question, then that means that no rephrase occurred to you. And there's your answer. No rephrase occurred to you. Okay. This problem, see, yeah, you gotta be super, rephrasing is not something you should deploy all the time. You should only do it when there is an obvious benefit and you are 100% sure. You know, for instance, let's see, what would be, like for example, if you were going to simplify something that was unsimplified in the, let me just make a screen for this. I mean, you'll see a lot of mention of rephrasing in places like books, but the biggest reason you see it there is because it fills the pages of books. I mean, it's a thing that you can write about on a printed page. And so you'll see it mentioned probably more than it should be. But, you know, the whole point of these questions is that they are very precise and very focused. And if you are not answering the right focus, you're not going to get the question right. So I would warn you to be very cautious about this. And do this only if there's an obvious benefit and you are 100.0000% sure that it works. I mean, for instance, one kind of question that you would want to change would be something that can be very clearly simplified. For example, if you have something like this, is A plus B minus C greater than A minus B plus C? Okay, well, you definitely want to play around with that with your normal algebra. So cancel A. Then add the B to both sides and add the C to both sides. And then you can divide by 2. Okay, well, that is pretty clearly a helpful thing to do. But in my book, this is kind of the only circumstance under which rephrasing is really worth it. Otherwise, it's easier to just address the question as asked. So, cautious. Not never, but just make sure you're doing it for a very good reason. That's all. I'm going to go ahead and skip trying to show algebra on the board here because putting algebra on this board is kind of annoying and slow. So what I will tell you is that there is no super obvious way to transform either of these into that, which is kind of what you would expect because the answer is E. So, because remember that when things are not sufficient, algebra is just kind of a giant bucket of fail. Like you just push variables around and nothing happens. That's kind of what happens when things are not sufficient. So if you try to manipulate these to look like that, you'll have residual terms that mess you up. I mean, you can try that and see where it goes, but just make sure that you are very quick to abandon that if you're doing it on test day and it doesn't work. So, all right, so still not sufficient even with everybody. So this is going to be E like elephant. Cool. All right, there's a couple people typing. Let's see what that's all about. And then we can move on to the problem. Okay, Brian, you're the only one still typing, so if you could either kind of hurry up or abbreviate, then that would be helpful. I know tablets have their limitations. But let's go ahead and just toss the next problem up there, and then we'll take the question. Oh, there it is. So is the point to prove that? Well, okay, that seems like a very baseline question about data sufficiency. I mean, that we had the discussion at the beginning. I think we answered this in the discussion that we had at the beginning already, unless I'm misunderstanding the question. But remember, you have these two possibilities, right? If it's greater than, then that's a yes to this question. If it's less than or equal to, that's a no to this question. The point is, if both of these are possible, then it's not sufficient, and if both of them are not possible, if only one of them is, that's sufficient. And the punchline of that whole earlier discussion was that the only one of those that you can try for is to get both. Like you can try that. You can, like, I'm going to see if I can make both of these things happen. You can't try for sufficient here. Sufficient represents trying to get both of these and failing. So that was the summary of that whole discussion. So in effect, yes. I mean, it doesn't work is the wrong way to say it, because it's not a question of does or does not work. It's a question of sufficient or not sufficient. But, and just make sure that you're using those words precisely, because that reflects your understanding of the problem. But yes, you're trying to prove not sufficient. Okay, let's move on to another problem. How about, let's say I'm going to give you exactly 30 seconds to do this next problem. Go. You have 30 seconds. All right, that's 30 seconds. Go ahead and pick something. Yeah, give me a thing. But remember, let's simulate this being the last problem on the whole exam, so you don't have the time to dilly-dally around with it. You shouldn't get yourself into a situation where you have only 30 seconds for a problem. But in life, you know, these things happen from time to time. Okay, well, what if you, I suppose, are just incredibly amazing at speed algebra, then you might be able to do that in that amount of time. But that's not really where I'm headed with this. I mean, what can we do with this in 30 seconds? Assuming that you are not so lightning fast at algebra. Ah, yeah, we can just estimate it. Yes, we can. So I think one thing that is probably clear right off the top is that it's not 1. Yeah, you're taking something that is already bigger than 3 and you're adding something to it and squaring it. But let's do better than that. I mean, this is this. We need to estimate that first. How big is square root 80, considering that square root of 81 is 9? So that's a little bit less than 9. Let's call that, I don't know, 8.9. Because we don't, you can probably tell that we don't want to call that 9, because if we do, then the right-hand term will just disappear. And it's bad if your estimation process ignores like everything in the world. So this is going to reduce to square root of about 17.9 plus square root of about 0.1 squared. Okay, now this is where you're like, wow, this is really small. So if you really don't have a lot of time, then you can estimate that as the square root of 18, approximately. And then, you know, you can just kind of ignore that because it's so small. So this is going to be about 18. Now, it doesn't mean you're done, and it doesn't mean the answer is D. Because maybe, maybe not. But let's estimate, like, as long as we're doing this whole estimating thing. what should we do with the answer choices? Should we do with I think my internet blipped out there for a second. The question is, I don't know if you heard me ask, the question is, what should we do with the answer choices? We should also estimate the answer choices. Yeah, absolutely we should. So, because I'm okay, I mean approximately 18, approximately 18. And you know, let's actually put that square root of 0.1 back in there now that we think about it, because that's not necessarily triviality. So, in fact, so what we have here, let me just remark, what we have here is a not so great estimate, but it's still going to eliminate a lot of choices. Yeah, you want to kill the choices that are way too far away from this. So 1 is ridiculous. 9 minus things, there's no reason to even consider. What's the best way to estimate how big 4 rad 5 is? I mean, you can probably tell this is a lot less than 18, so you might not even have to. But 4 rad 5. Yeah, rad 4 instead of rad 5 is going to have a lot of error. Here, tell you what, here's a process that you probably never thought about running in reverse. Like in school, they told you if you were given something like the square root of, I don't know, 50, then you would be told to simplify that. And that would give you, what would it be? 2 rad 25, so 5 rad 2. The problem is that if your goal is to estimate this thing, then this is way easier to estimate, and this is way harder to estimate unless you've memorized the square root of 2 to a ridiculous number of decimal places. I mean, the point is that these things are really easy to estimate. These are not. So this is like 7.1. This is easy. So so what you want to do is you actually want to unsimplify this. If your job is to estimate, then get it the heck out of this silly form. It gets look like that. So this is rad 60, rad 5, which is rad 80. Oh, hey, that's about 9. So this is only about 9. Way too small. Okay, so it's going to be one of these guys. Now, there's 2 ways to proceed here. The first way to proceed is to know what wrong answers look like. And this is not every wrong answer in the world. But if you look at 18, 18 is the kind of answer that people would guess if they just ignored the square root of 80s because they thought they canceled, and incidentally did algebra incorrectly too. But, I mean, this is what people would guess if they just squared the rad 9 parts and ignored the square root 80 parts. On the other hand, the 20, there is absolutely no obvious reason why the answer would look like this at all. Now, this is one of those things that some people never really think about this even after months and months and months of studying for this. But what I wrote in front of E is actually what makes E a better guess. Because one thing about this test that you guys should know is that obvious looking answers are almost always wrong. So that's how they roll. They got to make a test where the problems meet at your challenge level. I mean, they can't give you things that are super obvious. And again, if something could be guessed, then that would put it into the same category. You know, so this is a very good quality. Like if it's a non-obvious looking answer, then you should be more inclined to pick it when you have to guess. So if you had to guess blindly between 18 and 20, you would actually want to go with 20, just for that reason. And it does turn out to be 20. If you wanted to make a better estimate of this, if you had the time, if you were, you know, adept enough with this sort of thing, you can realize, someone tell me what, okay, 17.9, that's going to be, you know, what, 4 point something, like 4 point low. Well, you know, like 4 point low is like 4.1, 2, 3, that kind of thing. How big is that? Some people don't have an intuition for this. Some people do. How big is this? How big is square root of 0.1? Is it? Yeah, it's what Angel said. Because a lot of people think the square root of 0.1 is going to be like 0.0 something. And what that is, that's your instinct about square roots from regular integers, where the square root makes things get smaller. But that doesn't happen here, right? With decimals, it's the opposite. Remember that 0.5 squared is 0.25. And this is only weird because you normally see those as fractions. I mean, it's a trip to see it as a decimal doing that. But this is actually going to be something a lot bigger than 0.1. In fact, if you realize that 0.3 times 0.3 is 0.09, then that's pretty close. 0.09 and 0.1 are almost the same. So that 4 point something low plus about 0.3, that's about 4.5 or so, right? And that's going to be about 20. So this is a better estimate if you have those chops in dealing with decimals and stuff. Cool stuff. And there's a big, big, big lesson along the way about this, about how wrong answers are made. Any questions? Okay, you can expand this out and do algebra with it. Again, it's actually sort of routine algebra that would also be very time-consuming to put on this board. So we'll go ahead and skip that so that we can do other cool things with problems. Let's look at another one. How about that one? These ones, I don't know if you guys have the resolution on your screen for this, but you know, I think we just did this one recently in one of the geometry study halls, so let's not do that one. Let's do, I'm actually going to put a new one on a slide because organization was such a beast on that last one. And because I love you very much, I'm going to give you another organization problem. How about this? You'll see it in a second. Right now there's a huge screenshot for reasons I don't understand. But you'll see it on the screen momentarily. So you can still use various flexible methods to solve this thing. But the point is, it should be pretty clear when you look at this with your eyes. The point is going to be the organization here. Also, don't even sort of think that you have to finish this within 2 minutes. Because no, you don't have to. This is clearly many times longer than average. So you can take 3 minutes, 4 minutes, totally legit. Give it a shot. I don't understand the question. What happened? People are still working on the problem is what happened. But we should be about done here. Like at this point, if you are not basically finished and definitely going to get this right, you should just toss it, and you should guess. But yeah, it should be quiet when people are working on a problem. Of course, it's quiet. Ted, I think you may have just shown up, but here, this is where you find the answers to multiple choice questions. You find them there, underneath your name. Okay, we should be wrapping this up. Again, it's been for 4 minutes plus some extra time by this point, which is fine as long as you are definitely headed towards a goal. And again, there's no gray area here. It's one of those things that you have to learn to have good time management, is that there is absolutely no such thing whatsoever as I am kind of making progress. That doesn't exist. There's no such thing as sort of progress. You're either on your way or you're not. The best analogy that I have is, let's say you're driving somewhere and you're already late. Then you either know where you're going or not. It doesn't have to be exactly exact. If you know that you're headed towards a freeway that goes that way and you're looking for a ramp, then that's fine. But if you're just driving around at random and hoping that something happens, you will know that you're doing that. You shouldn't do it. Same thing with work here. If you're just wandering around, you got to turn in a lot earlier than 4 minutes. I mean, you got to stop as soon as you lose track of goals. Like the minute that happens, you got to stop. Okay. What level of question is this? Is a question that I don't answer because the answer is useless to the test taker. So there's no benefit to derive from that. It's a distraction, so there's no point in answering it. Okay, so let's talk about this. Let's organize. So this is not the word problem study hall, but still some comments are in order there. When you see a word problem, with this problem in front of you, this will be quite clear. But the hard part is the paragraph. Because paragraphs are just a horrible, horrible way of presenting math information. They're terrible. I mean, imagine taking your favorite sports, like you're following your favorite sports team. If you find them in a table of standings, that's easy. If that exact same information were in a paragraph instead of a table, think of how much harder it would be to find. It would be like, whoa, much harder. So what your goal should be is to organize, get the stuff out of the paragraph as soon as possible, and then think about doing math. So, but organize first just means make an empty chart or empty spreadsheet or empty something. I mean, this is where people go wrong in classrooms, is they try to the real life equivalent would be trying to fill in a spreadsheet before you even have one. It's kind of weird, but make an empty chart first. Just think about making a chart. Don't worry about doing anything with it yet. So as far as what goes in a chart, you just think about like headlines. So things that would be rows and columns of a chart. So we got take-home pay. It's monthly. And then there's also, let's just say what's going to go into our table. What stuff is going into a chart here? Well, all right, so we have monthly take-home pay. We have fractions saved. That's this one. This is the total amount of money saved. Notice that I'm not looking at math here at all. I'm just looking at stuff that can be row and column headings for the year, total saved. And then this is the monthly that she did not save. So let's put that up there with the monthly take home. Might as well put all the monthly stuff together. So you also have the monthly not saved. So even though this is not listed in there, we're going to want the monthly saved too. Because then these two items that are here will just add up to that one. So this is going to be the sum. In fact, we can write that relationship right now before we even have a chart yet. This equals this plus this. Okay. And then this is just confirming that this is the sum of those and there's no other source of money. And the fraction is actually already there. See, this is not nearly as intimidating as it looks. Because this is genuinely all the stuff in the entire problem. Yeah, it's the whole thing. But that's a big paragraph, but this is all the stuff. It's not as scary as it looks. As long as you do this as a separate step. If you're trying to do math at the same time, that's where it gets hard. Okay, so let's make a chart. Well, I mean, I would just write those things, those three. So, saved plus not saved. Let's say, okay, so you have monthly take home. You have a fraction. Monthly saved, and then you have monthly not saved, and then you have total saved for the year too. Let's shrink these a little bit. And NS stands for not saved there. And these are going to be columns. So we put dividers in there. Okay. And then the last thing we have in there is the annual saved. Okay. There. Not high tech, just columns. I mean, I don't see any way to make this into rows plus columns, so let's just not do that. Also notice what we noticed up there, which is that the monthly take home is the sum of this and this. Okay, so we can draw that on there too. Now let's get all the math information out of the paragraph at the same time. That's how you get efficient here. Because, okay, people who are still working on this thing after 5 minutes, I mean, I can't see your scratch work, but I would bet that you looked back at this paragraph probably 5, maybe even 10 times. That's where the problem is. The problem is looking at the paragraph a million times. Let's not do that. Here. The total amount of money that she had saved, that's that, was 3 times the not saved monthly. So that's a relationship. Let's just put that in there. If you take monthly not saved, then you multiply it by 3, then you get annual saved. And there. That gives you that. And then actually I think that's all of it. Yeah, that looks like that's it. I mean, other than, of course, annual saved, what else is annual money saved related to? They don't have to tell you this as long as you know that there are 12 months in a year. But this column is actually just a multiple of which other column? Yeah, it's 12 times the monthly saved, because the same thing is happening every month. So, all right, sure. And then the goal of the problem is to find the fraction column. That's this thing, this yellow thing is the goal of the problem. All right, well, that's great. I mean, this is not a pretty chart, but it is very much functional, and it will do. It will do for our purposes. It's plenty good enough. What is a way to do this that avoids variables? Because heaven knows if I just got done making this thing, I don't want to also have to deal with variables. Plug in numbers in what sort of way? Maybe. Although you can't plug in totally arbitrary numbers. But you can back solve, yeah, test answers is what we're going to call it, back solve. And then, so yeah, you can start from an answer choice. But then you can also take into account TK's suggestion of plugging in. Because when you back solve, that's just going to give you a fraction. But you still don't know the take-home pay. So you can also plug smart numbers for that. So there. I mean, you don't have to use the same take-home pay every time. For example, if this is 1/5, you can just use a take-home pay of 5. If this is 1/4, you can use a take-home pay of 4. I mean, you can change those things if you really feel like it. So let's say that we did C. Let's say we tried C in red. So C 1/4. I mean, because it might look like a 4th is a good try because this is a 3 and this is a 12, and that might remind you of a 4th. Although, again, you should be cautious of such things. So in that case, we can just pick 4 as the monthly take-home, because then that means we save 1. That means we don't save 3. Now, see, here's the problem. The problem is that if we follow the green arrow, then we get 9. But if we follow the purple arrow, then we get 12. I mean, that's not a thing. We have to get the same value twice. So this is odd. Can you just use fractions? What do you mean by the inverse, Mike? I mean, inverse is not really a math term, although to me the inverse of 2/3 would be 3/2, which is probably not what you're talking about. But maybe. You could do that, but notice you're still going to have this not fraction for this, because you have to multiply this by 3 to get the, I mean, everything else is an amount. Like, the amount of not saved per month is key because of this green arrow. I mean, you can't do the green arrow without it. So, it'll be 9/4. 9/4. I mean, you could input fractions. I would just rather deal with whole numbers. That's just me. I just like whole numbers better than fractions. That's all. I mean, if you plug in fractions, they will definitely work. That's beside the point. But yeah, fractions won't save time over whole numbers. That's for sure. I'll tell you that. But by the way, oh, okay, yeah, don't do that. Just the first thing that comes to mind, do it. Don't ever second guess methods because of, quote, trying to save time, unquote. Because the time that you're talking about right now is like 3 seconds, dude. It's a completely insignificant time savings. It will never make a difference. Yeah, 3 seconds, 4 seconds. It's not going to change your life. Can we tell whether this is too big or too small? Well, maybe it's obvious, maybe it's not. If it's not, then you just pick the other choice and go with it. Say we did B. B is third. That means we can pick a smart number of 3 this time. So that's still 1. Now that's 2. Okay, well, that's going to get even worse. Because now the green number is only 6, whereas the purple number is still 12. So this is even worse, even farther apart than C, which means that we're moving in the wrong direction. Notice that took no time at all. Really, it took like 8 seconds to plug that in. So don't deliberate endlessly over which way you are going in the choices. Just throw something in and see what it does. All right, that's wrong, so let's go the other direction. Let's try D. Let's try D in brown. 1/5. Let's pick a smart number of 5. Then that would be 1, and that would be the other 4. Looks like we're going to win this time. Because now that's 12. 4 times 3 is 12. And this is 12 times 1 is also 12. We win. It's D. Good stuff. Any questions about this? I mean, the back solving is also an emphasis here, and this is what ties this problem into today. But the main point here, of course, is this whole organizational bit. Just make sure that you separate out these tasks. I mean, if word problems are hard for you, then you are probably trying to organize and do math at the same time, or more to the point, you're probably not trying to organize. Probably what's really happening is you're just not doing it in the first place. But make sure you separate tasks that are separate. In this case, the task of making a chart is a thing. The task of filling it in is another thing. Don't try to do them at the same time. Because you can see that's where all the trouble comes from. You know, like in other words, making these columns was one step. Putting all these arrows in there going every which way, that was the following step. My brain would not be able to handle doing both of those at the same time. Wouldn't work. So don't make yourself do it. Just one step at a time. Monotasking, as it were. Single task at a time. Okay, looks like a couple people are typing questions about this thing. That's what you did. That would also work. Yeah, you can do that, sure. Is that if that's a question, I don't know exactly what the question is. But okay, then yeah, you can pick smart numbers because really what this is like a team of numbers that interact, right? Like once you have this fraction, this number and this number and that number are a team. So if you pick any one of those 3, then you have them all. So you can start from, like here, I just wanted to make sure these fractions led to whole numbers. So I picked these as integers that matched the bottom of the fraction. But if you want to pick this, you can do that too. Of course you can. So yeah, absolutely works. All right, let's see if we can sneak in one more. I guess the discussion of this is going to have to be super abbreviated, but Let's see if we can do this one. By the way, let me clear up one thing here, just in case anybody is thinking it. Someone tell me in the chat box, from start to finish, what are the numbers of the terms? Not what are the terms, but it's term number what through term number what. Do you guys know? A sub, like what is the first A sub and what is the last A sub? See, so some people are going to think it's 2 and 15. Okay, now let me tell you something about this test. The thing about this test is the test does not have stupid tricks on it. I mean, I made this point in previous study halls. But on this test, nothing is ever written or notated in weird ways. Really, it's not. So starting a sequence with term number 2 would be really freaking weird, and they're not going to do it. I mean, this sequence is actually A1 through A15. If you think about it, it starts, in fact, every sequence that you will ever encounter on the GMAT starts with number 1, always. You will never encounter a sequence that starts with anything else. If you're an engineer, you might see sequences starting with A0, but they don't do that here. The only reason this is a 2 is that if you think about it, if you plug in 2 here, that's A2 and that's A1. So you can't put a 1 here because then you would need a 0th term. So when they write a 2 here, they're actually telling you the first term is A1 because that's what the statement says. So that just make sure we're clear on that because that does matter here. But just any sort of tricky weirdness you throw out the window. If you ask yourself, would they start with the second term? The answer is no. No, they wouldn't. Let's just get a guess on the board in the next 20, 30 seconds to this, just so we can almost finish on time. If you have watched enough of these study halls in the past, then there's an answer that you know you don't want to pick. Okay, you may not be done considering this one yet, but I would guess that most of you who are still working are not really still working. You're probably just wandering around. Don't do it. Does anybody know what the epic trap answer here is that you do not want to pick? Don't do it. Yeah, this is classic C trap. If you don't know what we're talking about, here's a summary from previous. We have had entire study halls on the C trap, by the way. But this is the single most common form of trap answer that you're going to see in data sufficiency. This is a discussion for data sufficiency, which of course. Okay. If C does both of these things here, rather than telling you myself, I'll have Drake tell you. If C does both of these things, then don't do it. There. I mean, is it way too easy? Well, if you pick C here, let's just, I mean, and there are actually entire study halls on just the topic of this type of trap answer. So it's a very rich topic that comes up a lot. By the way, you'll see it on your GMAT too. If you don't think you saw it, you probably fell into it. First of all, the reasoning is, okay, I have really bad consistency of internet service on all these mini delays here. Okay, the reasoning is just, well, I have two terms, and there's a constant difference. So I have the whole sequence. Okay, well, this is way too easy. Now, what's even more important than the too easy part, because too easy is subjective. I mean, people who are very bright and good at manipulating things might mistakenly conclude too easy when it's not. But the other thing that C traps all have in common is they like ignore the entire point of the question. You know, like this. I mean, you are actually going to have to think about how many terms are greater than 10. I mean, that sounds like duh. But the point is, if you don't have to think about this, your answer is wrong. Period, full stop, end of story, no exceptions ever. You will never be able to ignore the focus of the question. That will not ever happen. And that's the real sin of picking choice C here, is you don't have to think about the question at all. If you are ignoring the focus of the entire problem the whole time, that's bad. Don't do it. Also, C, so C is a trap. I mean, don't pick it. There's like 20% of the problems above a certain level are this kind of trap in data sufficiency. Like, there's so many of them. Don't pick C because it's a trap. Don't fall into it. But also don't pick E, because E here would mean that, I mean, E is just logically an absurd answer. Because C, whenever it's a C trap, it will be, right? Like, this is a very juicy, delicious-looking trap. E is not even logically possible, because E would mean that even if I had the whole sequence, I somehow still could not answer this. Well, I mean, of course I could. Okay, so don't pick C and don't pick E. Don't do it. All right, well, now that we know not to do that here, let's test cases. Okay, what this means is you should actually just go ahead and draw 15 blanks. Yep, you should do it. 4, 5, 6, 7, 8, 9, 10. I mean, again, do not be afraid to do things like draw 15 blanks. It will never take anywhere near as long as people are afraid that it will. It will probably take you about 10 seconds, maybe even less. And then the question is, how many terms greater than 10? Now, this is A1. This is A8. Does anybody notice anything conspicuous about the position of A8? Ah, it's the median. That might be a thing, guys. But you know what the goal is, right? So here. And then we're going to just need to, these are going to be columns, actually, rather than, okay, let's just pretend that there are column dividers there. I don't want to draw 14 dividers. Okay. So how many terms are greater than 10, and this is just a constant. This means it's you adding the same number every time is what that means, this here. Constant. So it goes up by the same amount, or it goes down by the same amount every time. Could be either, right? Down by, in fact, if you combine the statements, you would get a sequence where k was negative. You don't ever have to combine them, but if you did. Okay, for statement 1, if A1 is 24, well, one sequence I might consider is just counting. If I do this, then all 15 of them are going to be greater than 10. All right, what's my only goal in life? To create a series in which what? Remember, it's a how many question. You get not sufficient. In this example, all 15 terms are greater than 10. So we just need to create a situation in which, in which any of them are. Because if the answer is not 15, then boom. So let's just subtract 100 every single time. 24, okay. The next term is going to be negative 76, negative 176, negative 276, etc. Okay, well, only one term is greater than 10. All right, so that's 2 answers. 2 answers means not sufficient. Again, those are super extreme examples, but that's the point. Like, if you do this with examples that are very emphatic, then you will remember much better how this worked if you go back and review it later. But they won't look like random scratch work numbers. Okay, statement 2. Let's do the same thing. Notice again, A8 is the median. And it's also 10. You might think that something is fishy about that, and you would be, of course, right. But let's just see what happens here. So this is now we're doing statement 2. Well, this is supposed to be 10. Notice what you're not allowed to do is 10, 10, 10, 10, 10, 10, 10, 10. If you could do that, it would screw everything and it would change the answer. But this has to be non-zero. It either has to increase or decrease. So notice if anything increases, look what's going to happen. It's going to be, because 10 is the median, which means that let's increase by 1, for instance, then everything to the left is going to be less than 10. And everything to the right is going to be greater than 10. So like these guys are all greater than 10. Exactly 7 of them. And if you increase at all, this is going to happen. I mean, if you increase by 2, it's going to be 12, 14, so the same thing will happen. And if you decrease, you'll get exactly the same thing, but just reversed. Now the big numbers are in front. There. So one of these situations will absolutely happen every single time, no matter what. And so it's always 7. Sufficient. And again, notice that you actually have to, surprise, surprise, you actually have to address the question to get this problem right. You don't find the sequence at all. The sequence could be any sequence with a median of 10, but the question is answered. For the B-boy. Focus, guys, the thing. If you are not thinking about the question, then your answer is wrong. I mean, this is also why I gave you that admonition about rephrasing at the beginning, because most people just take that ball and run way too far with it. Because rephrasing can be a tool, but the problem is people take it as a license to ignore the question, that's going to be a disaster if you do that. So you need to be very, very, very careful with that. But notice that the solution here totally addresses the question. You have to think about how many terms are greater than 10. Okay, we got to start wrapping up here, guys. But thank you for sticking around. And yeah, if k is more than 1, like I said, these are just representative examples. Because this is 10. If k is more than 1, these will just increase faster, but they will still be bigger than 10. Let's say if k is 10, it'll be 10, 20, 30, 40, 50, 60. Just go ahead and plug in the cases yourself and see. It'll do the same thing every time. What's key is that this is 10 and that this is also 10. That would definitely change the game if this were a different number. But it's not. It's the same number that's in the question. Okay. Other thing. Let's kill it, guys. Remember, there's no log out. You just have to quit the application. It's kind of weird, but that's how it works. But that is definitely how it works. So